There. All right, so today, this is part 2. This is pretty much the same thing we did yesterday. I'm gonna do harder problems with you. So the learning goal is still the student will understand how to graph proportional relationships, which what we just said a second ago when we graded was that proportional relationships go through the origin and they also are straight lines. So those are 2 things that we're looking for. All right, so our example number 1 says a salesperson earns 10% commission on sales of energy efficient appliances. Draw a graph to model this situation. Is the amount of commission proportional to the amount of sales, and how do you know? Okay, so we're going to have to come over here and we're going to have to create our own graph, and they're not giving us a lot of information here. So we're going to start with the table, because I told you anytime that we're going to graph, we're going to start with the table. Okay, what types of numbers would you like to put into our table if we are discussing energy efficient appliances? Do you guys know what energy efficient appliances are? Can you give me an example? What's an energy efficient appliance? Kurt. A refrigerator. Caleb.
One of those light bulbs.
Now that wouldn't be an appliance. I mean, that's energy efficient, but this says appliance. So what else would be an energy efficient appliance in your home?
A fork.
A what?
A fork.
A fork? No, a fork is not an energy efficient appliance. Gavin. Possibly. Kurt.
A microwave.
Microwave. Kurt or Caleb.
A blender.
I'm thinking more washer, dryer.
Sink.
No, sink is not an appliance. Okay, appliances. Washer, dryer, maybe a water heater.
Spoon. Air conditioner.
Not an appliance, guys.
Air conditioner.
No,
like square.
no, that's not an appliance. Energy efficient appliance means has to be plugged in. You're using electricity. Yeah, we don't really think about okay, hold on. Energy efficient things are things that save electricity when you use them all the time. Refrigerators plugged in all the time. Washer and dryer you use, like we use ours for an entire weekend.
Air conditioner.
Air conditioner.
Oh.
Devin.
One of those on battery-powered cars.
No, we're still not in. Okay, yes. What?
Like oven.
Oven, possibly. Water heaters, furnace, all those things that run either your apartment or your home are energy,
Lights.
possibly garbage disposer. That's not an appliance. Dishwasher, those are appliances. Okay, good. Now, think about how much those things cost. Are they in the tens of dollars, like a refrigerator costs $10, $20, $30, or does it cost hundreds of dollars? Hundreds, or sometimes, sometimes thousands. So when I'm counting here, what should I count by? Hundreds. Okay, that is reasonable. Okay, because dishwashers are hundreds of dollars. Okay, refrigerators are hundreds of dollars, if not thousands. Okay, so you have to think sometimes what type of scale you're going to need to count by. Okay, well, if I buy 0 energy efficient appliances, then I spend 0. Okay, now they earn 10% of sales. Every time they sell, they get a bonus of 10%. So how do I find 10% of 100? Multiply. So I'm going to take 100 times 0.10, because that's 10%, and that would be $10. So they earn $10. Okay, what would 10% of 200 be?
20.
Very good. 20. Okay, 10% of 300. 30. 10% of 400. And 10% of 500. 50. Okay, so now I can come over to my graph and I can graph this. Okay, I need to decide what I want to count by here. I have this much space. I want to use up as much space as possible. So even though I counted by hundreds here, would it make sense to say, okay, if this is my 0, what if I skip a line? Would that be okay here? What would this line represent? 50. Is that okay in this situation? That's okay, right? If he could sell 150 or 250, so it would totally make sense to skip a line here. and I still get in my 500, which is what I put on my scale. Okay, what do you think I should count by with my commission? Okay, if I go by tens, I get 10, 20, 30, 40, 50. I use only that much of my graph. So maybe count by fives, and you could probably argue it either way, but you want to use as much graph as possible. So if I go ahead and skip a line again, that means I really counted by fives. 40, and I get exactly up to 50. All right, so then I'm going to go ahead and graph my points. 0, 0. I'm going to go over 100 and up 10. I'm going to go over 200 and up 20. Then my next question, is it okay to draw a line through these points? Okay, if you say yes, why is it okay? Kurt? Say that again? Right, because appliances can cost anywhere. They could be anywhere on here. It's not like I go to Nebraska Furniture Mart and it's only 100, only 200, only 300. They might charge me $359 for a new dishwasher. That's okay. And so that's why I can draw a line, because this data is continuous. That's what that's called. And this would go on forever, because there are things that easily cost over $500. So this will continue to grow until infinity, until I run out of things that I could purchase. Okay, so this is okay because it's okay to have amounts between these. And sometimes that's going to be okay and sometimes it's not. Okay, all right, I'm going to have you guys kind of try one. I'm going to help you get started and then see how much of this you guys can do, because this would have been the got it. Okay, all right, it says at some airports you pay a tax of 14% on the cost of a car rental. Draw a graph to model the situation where the horizontal axis is the cost of the car. So right here they're telling you horizontal cost of the car, and the vertical is the amount of the tax. So vertical is the amount of the tax. Is the amount you pay in tax proportional to the cost of your car rental? How do you know? Oh, we forgot to answer that up here. Is this a proportional relationship? Can you tell me why? Goes to the origin. And it's straight. And straight line. Okay, so you want to make sure that you understand that. Okay, so let's go ahead and kind of get this set up and see what you guys think. All right, so horizontal axis. Horizontal would be this one, and that says it is the cost of the car. So that's what your X is going to represent, your cost of your car. And your Y axis is going to be the amount of tax. Luke, are you finishing up your sheets? Okay, now you guys might not know how much a rental car costs. Does anybody have any clue?
Yep.
A couple of you do? Kurt? How much?
$100 a day.
Yeah, if you're renting a fancy car, it could easily be $100 a day. Shane, did you have an idea? No? I mean, they really vary. Like, yeah, if you're going to go rent some, like, souped up something, like I had to get a Yukon one day because my car, and that's all they had, not because that's what I picked. And I think it ran like $80 or $90 a day to rent it. But it just kind of depends. So I would say on this, you could count by 50s or 100s, or kind of what you pick. Probably not 10s, because it's going to cost more than $10 even to rent a teeny tiny car. So
A Yukon?
yeah, it was a Yukon. It was pretty fancy. I drove up to school and Mr. Stanley goes, "Did you get a new car?" And I was like, "No, it's just my rental." And I felt like I could crush everything as I was driving because it's huge. You guys know those? They're monster. I mean, they're huge. So I'm driving down the road, and I just feel like I can crush all the tiny cars as I'm driving. Just saying. All right. How am I going to figure out the amount of tax on these? Good. Multiply by 0.14. Okay. So if I say the cost of the car is 0, how much tax do I have to pay? 0. All right, so then I'm going to have to grab my calculator and figure out my amount of tax. So I'm going to have to take 50 times 0.14, which I'm getting 7. And then if I take 100 times 0.14, what should I get? 14, good. 150 times 0.14? Oh, goodness. Okay, what should the next one be? And the last one? 35. Good. Okay, so we're going to go ahead and put in our x-axis and our y-axis. All right, so again, think about, you want to use this whole space, or as much of this space as you can, and we've got cost of a car, and we counted by 50, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I could use this much space, or I could try to use this much space. So what do you think I should probably try to count by here?
25.
Probably 25s. But what I could do, make sure you start first one with a 0. A lot of you guys sometimes forget that. And then I can go ahead and skip a space and put in 50, because that means I am counting by 25s. But then I don't have to mark every single line, which is kind of nice. And now I've used all of that space and not just a teeny part of the graph. All right, then I need to put in my y. So what do you think my scale should be with my y? So if I do 7s, how far will that get me? I would go up 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then I only use that much of my graph. So should I maybe skip a line and go up by 7s, and then I'm technically counting by 3.5? Does that make sense? Okay. So I skip a line and then I go by 7, so I'm actually counting by 3.5s. And then that allows me to use a lot more of my graph. Can I draw a line between these points? Yeah, is the cost of the car going to be exactly $50? No, it's probably going to be like $55.37 or whatever it is. So because I can have points in between these two, I can go ahead and draw a continuous line. All right, now we're going to look at some that are negative. So these are a little bit trickier. You guys good on that one? All right, so let's look at this one. It says ice forms at 0 degrees Celsius. The surface temperature of the ice on an ice rink decreases 0.5 degrees Celsius every hour. Draw a graph to model this situation. Start when the surface temperature of the ice is 0 degrees Celsius. Is the surface temperature of the ice proportional to time? How do you know? Okay. So again, I'm going to start with an x and a y. Okay. They are telling me that the ice forms at 0 degrees Celsius, which is where they want me to start. So that means 0 degrees at time 0. So this is going to be my time. This is going to be my temperature. So at time 0, my temperature is 0. And it says it decreases every hour, which means I want to count by hours and count by ones, because that's what it's telling me to do. So 1, 2, 3, 4, 5. Okay. What's my temp doing after hour 1? Decreasing by 0.5. So that's negative 0.5. What would it be in 2 hours? Negative what? 0.10? No. Negative 1. Because it's decreasing a half a degree each time. Okay, at 3 hours? Good. 4 hours? Good. Very good. Okay, now I want you to think about this. This means if I'm on a graph, okay, here's a graph, that means I want my time to go over, but then my temperature is going to go down. Does that make sense? So my graph is down here, which means I do not need any of these other quadrants. I just need this bottom quadrant. So my graph here is going to look quite a bit different than my other ones. My graph here is going to look like this because I just need this bottom portion. Okay, so my x is going to be here, and that's going to be my time, and my time is in hours. My side is going to be temperature in degrees. Degrees Celsius, actually. All right, and then I went over to 5. Can I do time in half an hours? Can I say 1.5 hours, 2.5? Yeah. So it would be okay here again if I skip a line, because that would be, I have 5 hours, but it's okay. The temperature would still be changing at half an hour. So this could be my 1 hour, 2 hours, 3 hours, 4 hours. Oh, I am going to run off just a little bit. We're going to say that's okay. 5 hours. Run off just a little. All right, and then let's count our temperature. We went from 0 to 2.5. What do you think I should count by here? Okay, so if I go 0.5, 1, 2, 3, 4, 5, I'd have 5. So this would be 0.5, 1, 1.5, 2, 2.5. I'm only going to get to there. So by quarters, 0.25. Okay, which means that I'm literally just skipping a line again. So this would be 0.25. This would be negative 0.5, negative 1.0. Let's see here. 0.5, 1.5. There we go. So I'm technically counting by 0.25. All right, then we're going to graph it. And this one's off a little, but we're going to pretend. Okay, so we want to talk about again, is this data continuous? Meaning that at 15 minutes, could I measure the temperature of the ice? At 20 minutes, at 30 minutes, at 45 minutes? It doesn't just have to be every hour. So because of that, this is continuous data, which means I can go ahead and draw a line in between each one, and it would continue to decrease until a certain point, because at a certain point it will stop decreasing. It can only get so cold. But for ours, we can go ahead and draw a line. So lots of things to think about when you guys are doing graphs.